Okay, so we'll go for the next important portion. It's a very important portion in Newton's law, extremely important in Newton's law. And name of the portion, write down, heading likho, constraint relation. Heading likho, constraint relation, extremely important, very important. So first write down the definition. इसका definition लिखो, फिर उसके बाद हम देखेंगे how to derive the constraint relation and how to apply constraint relation in Newton's law. ठीक है? तो first write down the definition. लिखो the relation among displacement vectors, the relation among displacement vectors, velocity vectors and acceleration vectors, displacement vectors, velocity vectors and acceleration vectors of all the movable objects of a given system is called as a constraint relation. Is called as the constraint relation. इसका मतलब क्या है? Suppose in a particular system there are number of objects and all the objects are moving. Suppose the objects are, let us say, object number 1, object number 2, object number 3, object number 4, like. And suppose there are displacement vectors are S1, S2, S3 and S4. What is the relation among these displacement vectors S1, S2, S3, S4? Whether S1 plus S2 plus S3 plus S4 is equal to 0. Whether S1 plus 2S2 plus 3S3 minus 4S4 is equal to 0. Or S1 minus S2 plus S3 plus 5S4 is equal to 0. कौन सा relation इसमें valid है? That relation is called as the constraint relation. Similarly, अगर there are velocity vectors, if there are velocity vectors are, let us say V1 plus V2, V3 and V4 respectively, whether V1 plus V2 plus V3 plus V4 is equal to 0 or V1 is equal to 2V2 or V3 is equal to minus V4, कौन सा relation इसमें applicable है, actual relation है, that relation is called as the constraint relation. So whatever mathematical relation you will establish among the displacement vectors, among the velocity vectors, among the acceleration vectors of all the movable objects in a given system is called as the constraint relation. It's called as the constraint relation. ठीक है? आगे लिखो. To derive the constraint relation, the following steps are useful. The following steps are useful. That means now I am saying the following steps. कुछ मैं steps बता दूंगा जो step को use करके आप constraint relation derive कर सकते हो, constraint relation find out कर सकते हो. ठीक है? तो ये सारे procedure आपको याद रखनी है. These are very important procedures to derive the constraint relation. Step number 1 लिखो, write down step number 1, clearly लिखो. Step number 1, choose a reference line. Choose a reference line. Within bracket लिखो. In most of the cases, the fixed pulleys can be chosen as the reference lines. The fixed pulleys can be chosen as the reference lines. मैं बता दूंगा उसका मतलब क्या है. Step number 2, give position vectors of all the movable objects with respect to the reference line chosen. Give position vector of all the movable objects with respect to the reference line chosen. Position vectors. Step number 3, calculate length of the strings. Calculate length of the strings in terms of the position vectors. In terms of the position vectors. That is step number 3. Step number 4, differentiate the above equation. Differentiate the above equation to establish the constraint relation. Differentiate the above equation to establish the constraint relation. ठीक है? तो ये सारे जितने भी steps मैंने बताया, all the steps has to be remembered, has to be memorized. इसको याद रखो. अभी मैं इसका application बताऊंगा. I am taking a very simple case, and the simple case is that suppose this is the ceiling here and this is the pulley. Suppose a string is passing over the pulley. A string is passing over the pulley, and there are two blocks attached. One block is here and another block is here. Let us say. Suppose this is block number 1 or object number 1, and this is block number 2 or object number 2. Suppose the mass of the two objects are different. If the mass of the two objects are different, then whenever system will be released from rest, the heavier object will go downward and the lighter object will go upward. ये problem हमने already कर चुके हैं. Suppose I am assuming this object number 2 is heavier and object number 1 is lighter. That means if this object will be going downward, this object will go upward. And from observation we know that, ये प्रॉब्लम ऑलरेडी हमने कर चुके हैं. From observation we know that at any moment अगर इसका वेलोसिटी डाउनवर्ड होगा, उसी मोमेंट में इसका वेलोसिटी अपवर्ड होगा विथ द सेम मैग्नीट्यूड. इसका एक्सेलरेशन अगर डाउनवर्ड होगा, इसका एक्सेलरेशन उसी मोमेंट में अपवर्ड होगा एंड ऑफ सेम मैग्नीट्यूड. During a certain time interval, if this object goes down by s, let us say displacement s, this object will go up by same magnitude of a displacement but in the opposite direction, that means in the upward direction. That means अगर मैं पूछूंगा what is the relation between their velocity vectors, इसका velocity बीच में relation क्या है ना, velocity vector of these two objects are equal and opposite. That means if one is v1, other is v2, v1 is equal to minus v2, equal magnitude, opposite direction. इसका मतलब v1 plus v2 is equal to 0. If v1 is equal to minus v2, then v1 plus v2 is equal to 0. Similarly, a relation between their acceleration vectors will be a1 plus a2 is equal to 0. If one is a1, other is a2, a1 and a2 are equal in magnitude and opposite in direction. So a1 plus a2 is equal to 0. Similarly, for a displacement vector, you can write s1 vector plus s2 vector is equal to 0. लेकिन हम ये कैसे बता रहे हैं कि v1 plus v2 0? कैसे बता रहे हैं a1 plus a2 is equal to 0? Simply by observation. Observation से हम इसको बता सकते हैं. Why? Because this system itself is a very simple system. Only two block system and single pulley. लेकिन अब assume करो, suppose ऐसा है कि मैं complicated system लूंगा जहां पर 10 objects होंगे, 10 objects will be there and let us say 5 pulleys will be there. If there will be 10 objects and displacement vectors are s1, s2, s3, s4 up to s10. Velocity vectors will be v1, v2, v3 up to v10, and acceleration vectors will be a1, a2, a3 up to a10. Then how to derive the relation between a1 and a10? Let us say v1 and v10, v4 and v5. इनके बीच में relation क्या होगा? It is very difficult to derive the relation simply by observation. Observation से हम लिख सकते हैं अगर सिस्टम सिंपल है. लेकिन अगर सिस्टम कॉम्प्लिकेटेड है, नंबर ऑफ पुलीज आर मोर, नंबर ऑफ ब्लॉक्स आर मोर, देयर सिंपली फ्रॉम ऑब्जर्वेशन इट इज वेरी डिफिकल्ट टू डिराइव द कंस्ट्रेंट रिलेशन. तो वहां पर हम क्या करेंगे, जो स्टेप्स मैंने बताया, यू हैव टू फॉलो दोस स्टेप्स टू डिराइव द कंस्ट्रेंट रिलेशन. देखते हैं वही जो स्टेप्स है ये यहां पर वर्क कर रहे हैं कि नहीं. वैसे बाय अप्लाइंग दोस स्टेप्स, first we will see here whether v1 plus v2 is coming to be 0 or not. We know that v1 plus v2 must be equal to 0. Whether a1 plus a2 is coming to be 0 or not. Okay, so let us apply those steps to derive the constraint relation in this simple case. What is step number 1? Step number 1 says that choose a reference line. Normally जहां पर fixed pulley मिलता है तो वहां पर fixed pulleys can be chosen as the reference line. But suppose in a system there is no fixed pulley, all pulleys are movable, then in that case ground can be chosen as the reference point. So if fixed pulleys are available, fixed pulley will be considered as the reference point, but if fixed pulleys are not available, then ground can be considered as the reference point. So in this case, since a fixed pulley is available, मैंने इसको assume किया this is the reference line or reference point. Next step, position vectors of all movable objects has to be given with respect to the reference point or reference line. This is object number 1 and this is object number 2. Let us say position vector of object number 1 is x1 and the position vector of object number 2 is let us say x2. Similarly, जितने भी movable objects होंगे तब सारे का हम position vector ऐसे दिखाएंगे, let us say x1, x2, x3, x4, x5 up to x10. Next step क्या है? Find length of the strings in terms of a position vectors. Find length of the string in terms of a position vectors. यहाँ पर देखो कितना string है? Obviously string is only one. The string that is connecting the movable objects is only one because the same string is passing over the pulley and like this here. So यहाँ पर only one string is available, then we have to calculate what is the length of the string in terms of a position vectors, means in terms of x1 and x2. Obviously, the total length of the string is equal to x1 plus x2. Total length of the string is equal to x1 plus x2. So I am writing here x1 plus x2 is the total length of the string, that is equal to L. लेकिन हमें पता है total length of the string is always a constant quantity. क्योंकि if this object will go downward, this object will go upward. If x2 will increase, x1 will decrease, but x1 plus x2 total length of the string is always constant. ठीक है? That means x1 plus x2 is a constant quantity, that is length of the string. What is x1? Position vector. What is x2? This is another position vector. लेकिन हमें पता है differentiation of a position vector is velocity vector and differentiation of a velocity vector is acceleration vector. तो अगर ये इक्वेशन को हम डिफरेंशिएट करेंगे then dx1 by dt plus dx2 by dt is equal to differentiation of L, but since the length of the string is a constant, its differentiation will be 0. So finally, this V1 plus V2 is equal to 0, जो हमें पता था, that is being derived here, V1 plus V2 is equal to 0. If V1 plus V2 equal to 0, that means the velocity vectors of two objects are equal in magnitude and opposite in direction. Similarly, if the velocity vector relation is established, you go for another differentiation, one more differentiation. That means A1 plus A2 also will be equal to 0. So this is the relation among the acceleration vectors also. ठीक है? So this is the simplest case. उसके लिए हमने पहले फॉर्मूला पता था and also we derived it is same thing is coming here. V1 plus V2 is equal to 0. A1 plus A2 is also equal to 0. आगे हम प्रॉब्लम सॉल्व करेंगे. If a number of pulleys will be given, number of blocks is given, then the same procedure will be adopted, same steps will be applied to derive the constraint relation. And one more thing बता दूं यहाँ पर जितना strings होगा उतना number of equations आएगा. यहाँ पर only one string is available, that means number of equations will be 1. If two strings will be available, number of equations, constraint relations or constraint equations will be 2 and so on. ठीक है? So ये steps सारे याद रखो, अभी memorize करो. Now we'll go for the further application. Okay, so make this figure, ये figure बनाओ. In this figure, this is the fixed pulley here, and a string is passing over the fixed pulley, and again it is passing below another pulley, and it is connected to the ceiling here. This is a block, this is another block, and this block is connected by a string to the center of this pulley. Here there are three movable objects. This block is movable, this block is movable, and this pulley is also movable. Three movable objects, two blocks and one pulley. Establish the constraint relation. Establish the constraint relation. Try करो. Okay, so अगर हम यहाँ पर वो steps apply करेंगे, reference line. So since this pulley is fixed here, we can choose this as the reference line. Position vectors of all movable objects. There are three movable objects. Position vector of this one is, let us say, x1 here. Position vector of another block is, let us say, x2 here, and the position vector of this pulley is equal to x3 here. So x1, x2 and x3. ठीक से फिगर को देखो. How many number of strings are available? Means movable strings. How many number of movable strings are available? Number of strings available are 2. कैसे? ये एक long string है. The string is passing like this. ये एक long string है. And another movable string is this one, which is connecting the pulley and the block number 2. This is also movable, but this is not the movable string here. तो इसको अकाउंट में नहीं लेनी है. Only we have to calculate the length of the movable strings here. What is the length of the first string? जो bigger string है, इसका length कितना बनेगा? Length of this string from a geometry, you see, this part is x1, this part is x3, this part is also x3. The total length of the string is equal to x1 plus 2x3. Total length of the string is equal to x1 plus 2x3. तो मैं लिखूंगा यहाँ पर x1 plus 2x3 is equal to, let us say, L1. From a geometry only you have to calculate what is the length of the string. नॉर्मल यहाँ पर बच्चे कंफ्यूज होते हैं, बोलते हैं सर ये पार्ट हम अकाउंट में लेंगे या पे नहीं लेंगे. आप ले सकते हो, नहीं भी ले सकते हो. Why? Because during the motion of a blocks, this portion is actually remaining fixed. ये पोर्शन का लेंथ कभी चेंज नहीं हो रहा है. That means this portion is constant. अगर मैं यहाँ पर कांस्टेंट ऐड करूंगा, लेकिन डिफरेंशिएशन ऑफ कांस्टेंट इज ऑलवेज इक्वल टू 0. तो अगर मैं कांस्टेंट ऐड करूंगा आफ्टर डिफरेंशिएशन, उसका वैल्यू 0 हो जाएगा. दैट मींस यू कैन टेक और आल्सो यू मे नॉट टेक. ओके, सो टोटल लेंथ ऑफ द स्ट्रिंग ऑफ द फर्स्ट वन इज नोन. व्हाट इज द लेंथ ऑफ द सेकंड स्ट्रिंग? ये छोटा सा स्ट्रिंग है, इसका लेंथ कितना बनेगा? दिस इज इक्वल टू x2 एंड दिस इज इक्वल टू x3. सो लेंथ ऑफ अदर स्ट्रिंग इज इक्वल टू x2 minus x3. So x2 minus x3 is equal to length is equal to L2. ठीक है? तो once the length of the strings are known, after differentiation you will be getting the velocity vector constraint, and one more differentiation will give you the acceleration constraint. अगर मैं differentiate करूंगा, then v1 plus 2v3 is equal to 0 and v2 minus v3 is equal to 0. v1 plus 2v3 is equal to 0 and v2 minus v3 equal to 0. This is velocity constraint. Acceleration constant also will be of the same nature. V के जगह में a आ जाएगा. That means a1 plus 2a3 is equal to 0 and a2 minus a3 is equal to 0. Velocity constant and acceleration constant. So simple. ठीक है? Okay, so next one more application, one more problem. पहले ये फिगर ठीक से बनाओ, फिगर बनाओ. Here basically in this figure there are 4 movable objects, 3 blocks and 1 pulley. 3 blocks and 1 pulley. This is the fixed pulley. String is passing like this. One end is connected to the block, other end is connected to one more pulley. Another string is passing over this movable pulley and 2 blocks are attached. This is object number 1, 2, 3 and 4. Establish the constraint relation. Establish the constraint relation. Steps apply करो, try करो. Okay, once again, step number 1, a reference line. The fixed pulley will be considered as the reference line. Position vector of all movable objects. This is, let us say, x1. This is block and the position vector is x2. This is another block. Position vector is x3 here, and this is pulley. Position vector is x4. ठीक से देखो, x1, x2, x3 and x4. How many number of movable strings are there? One second, 2. This one and this one. What is the length of the first string? ये जो string है इसका length क्या बनेगा? Left hand side में इसका length x1 है, right hand side length is x4. Then length of the string becomes x1 plus x4 is equal to, suppose, L1. x1 plus x4 is equal to L1. But what is the length of the second string? You see clearly from the geometry what is the length of the second string. What is the length of the left hand side portion? Length of a left hand side portion means length of this portion. This is the total length, means x2 minus x4. So length of this portion is equal to x2 minus x4. Length of this portion will be equal to x3 minus x4. x2 minus x4 and x3 minus x4. That means the total length of the string now, this is x2 minus x4 plus x3 minus x4 is equal to L2. That means finally I can write x2 plus x3 minus 2x4 is equal to L2. So this is string number 1 and this is string number 2. Once the length of the strings are written, उसके बाद velocity लिखेंगे. x की जगह में v आ जाएगा, फिर v की जगह में a आ जाएगा, l की जगह में 0 आ जाएगा, because differentiation will become 0. That means v1 plus v4 is equal to 0 and v2 plus v3 minus 2v4 is equal to 0. This is the velocity constant. And acceleration constant फिर वही बनेगा. That means a1 plus a4 is equal to 0 and a2 plus a3 minus 2a4 is equal to 0. Velocity constant and acceleration constant. ठीक है? Okay, so make one more figure. A figure ठीक से बनाओ, पहले figure बनाओ. In this system there are total 6 movable objects. 6 movable objects, 4 blocks and 2 pulleys. 4 blocks and 2 pulleys. This is a string passing over the pulley. This is the block. A string is passing over, this is another pulley. A string is passing over the pulley and 2 blocks are attached. String is passing over this pulley and again 2 blocks are attached. ये figure ठीक से बना. Establish the constraint relation. Establish the constraint relation. Try करो. Procedure exactly remains same. Once again we are choosing, this is the reference line. Since there are 6 movable objects, that means we have to show 6 position vectors. This is, let us say, x1. ठीक से देखो. This will be equal to x2. Position vector is x2. This position vector is x3. This position vector will be equal to x4 here. This position vector is x5 and this position vector will be equal to x6. So position vector of all the movable objects are shown. Now we have to write the total length of the strings. How many number of strings are there? Number of strings are 3. This is 1, this is 1 and this is 1. Since 3 strings are there, that means we have to write 3 constraint equations or 3 constraint relations. What is the length of the first string? अगर मैं बताऊंगा ये string number 1 है, इसका length क्या बनेगा? Length of this portion plus a length of this portion. Length of this portion is equal to x1 minus x5. That means this is equal to x1 minus x5 plus length of other portion. This is equal to x2 minus x5 plus x2 minus x5 is equal to L1. That means x1 plus x2 minus 2x5 is equal to L1. This is equation number 1. Length of other string, ये जो string है that is passing over the fixed pulley, length of left hand side portion is x5, length of the right hand side portion is equal to x6. That means x5 plus x6 is equal to L2. This is equation number 2 here. Other string, length of this portion is equal to x3 minus x6, length of this portion is equal to x4 minus x6. That means this is equal to x3 minus x6 plus x4 minus x6 is equal to L3. So finally it becomes x3 plus x4 minus 2x6 is equal to L3. That is equation number 3. So if the length of a strings are known, simply after differentiation you will get answer. That means अगर मैं directly velocity का constant लिखूंगा, so v1 plus v2, v1 plus v2 minus 2v5 is equal to 0. v5 plus v6 is equal to 0 and v3 plus v4 minus 2v6 is equal to 0. These are the constant relation for velocity. Similarly, in place of a velocity you write acceleration, you will be getting 3 acceleration constant relations. 3 acceleration constant relations. Only you have to use geometry to calculate the length of the strings. अगर length of the string correct हो गया तो constant relation भी आगे correct आएगा. ठीक है?